Okay, this is, I'm going to work out the solutions to the problems on first exam. So problem 1 is just to do a little bit of arithmetic. We want to calculate this fraction, 7 minus 1 over 1 plus 2 over 16 minus 2 over 7 plus 5 over 3. So this number is a fraction, and this is the command that converts it to a decimal. That's all it is. Problem 2, we have a polynomial we want to factor. So the polynomial is 3 times x to the 8th plus x to the 7th. Oops. Have to do it right. 3 times x to the 8th. Move the cursor over. Oops. And this is supposed to be times, not an 8. 3 times x to the 8th plus x to the 7th minus 10 times x to the 6th minus 10 times x to the 5th plus 4 times x to the 4th plus 27 times x cubed plus 8 times x squared minus 12 times x minus 14. So let's see if that's correct. 3x to the 8th plus x to the 7th minus 10x to the 6th minus 10x to the 5th plus 4x to the 4th plus 27 times x cubed plus 8x squared minus 12x minus 14. That's the polynomial, but we want to factor it. And the command to factor a polynomial is just factor. And so factor that, put the polynomial in parentheses. So that's what happens when you factor it. That's kind of simple enough. Problem 3 is to find an equation of a line that passes through a certain slope, through a certain point, and has slope minus 13 over 22. So we use the point slope formula, which we've used many times and you have to know. So I'll just call it line. So the line is given by the slope, minus 13 divided by 22 times x minus 8/5. That's the x coordinate of the point that it goes through, plus 9 over 4. So that's the line. And if we plot the line, that's what it looks like. Of course, the y-intercept we just call it that. That's just where the line crosses the x-axis, the y-axis. That's 703 over 220. That comes right from the equation of the line. Another way of doing this is It's what happens when you substitute x equals 0 into the line. And you get, of course, the same number. And the x-intercept, that's where the line crosses the x-axis. That's the value of x when y is equal to 0. So that's what you get when you solve the equation. The line equals 0 for x. Or another way to do this is you solve the equation equals 0 for x. Okay? Exactly the same thing. So yeah. So this is the y-intercept, and this is the x-intercept. Next comes problem 4. Find all solutions of a certain equation. So it's a complicated equation. We should use fsolve. And the equation is 2 times e, which we have to write as exp, e to the minus x squared over 15 equals 2 plus the sine of x minus 1. So that's the equation, and we want to solve it for x. And Maple gives us one solution, but there might be others. So the best way to check is to plot this. So if we plot this curve and this curve, the points of intersection are the solutions. Suppose we plot then on the same graph this equation and this equation. So this is really very interesting. So you see the sine wave, that's this, and the exponential function is this, and they cross at 2 points. But Maple only gave us one of them. Let's see, let me convert this from radian measure to numbers. So let's graph this maybe from x equals -7 to 7. So you can see this point, that's probably this 0.895. And what about this? We have to look for a negative number. So we have to force Maple to look for a solution for negative values. So we say fsolve, but now let's give a range of value for x going from maybe -4 to 0. And now we get the negative solution. But we really had to force Maple to do this. So here's one solution and here's the other. Without prodding, Maple found one solution but didn't find them all in this case. But looking at the graph, we know there are 2, and then we have to search for it explicitly. Just save because it's too easy to lose stuff. Okay, that was problem 4. Problem 5. we have to take a certain limit. So the limit of what? So I have arctangent of 2 times x minus the cosine of 1 over x, all divided by 1 plus 5 times exp of minus x. And I want the limit as x equals infinity. Oh, I put an equal sign there, and that's supposed to be a plus sign. Now it looks right. Arctangent of 2x minus the cosine of 1 over x over 1 plus 5 e to the minus x. This just states the problem. It doesn't give me the answer because I used a capital L for limit. So let me just write this with a capital L equals the same thing with the lowercase l, and that's the answer. So that's really kind of interesting, but that's the answer. Problem 6, we introduce the function f. X goes to the cosine of 2 times x minus e to the power x to the 7th. Okay. That's my function. Cosine of 2x e x to the 7th. And the derivative of f is that function. Or if I evaluate it at x, it's that. Same thing. Nothing easier than finding the derivative of a function in Maple. Okay. Problem 7, we have another function. F of x is going to be the square root of x to the 4th minus x plus 1. And we want to find the tangent line and the normal line at x equal 1. So tangent line, this is the line whose the slope is the derivative of f evaluated at 1 times x minus 1 plus the value of the function at 1. That's the tangent line. Maple does all the work. And the normal line is almost the same. It's the line passing through the same point, but the slope is the negative reciprocal. So the slope should be minus 2/3, and it is. So let's just see if this works. Let's plot 3 things. The function f of x, tangent line, and normal line. Now, of course, these 2 lines don't look perpendicular, and that's because we haven't used scaling constrained. So let me control click, scaling constrained. Aha. And now you can see these two perpendicular lines. Suppose, let me make this, x goes from minus 10 to 10. And then we also put a bound on the y's. Say y goes from minus 10 to 10. So now you can see it very nicely. The green is the tangent line at this point, and the blue is the normal line. And they look perfectly perpendicular. Problem, oops. Oh, I'm sorry. So I actually conflated two problems. So problem 7 was to compute the tangent line and the normal line. And this was problem 9, to plot the two of them together. So the next is, oops, sorry, problem 7, this is problem 8, this is problem 9. So we have another function, let me just call it, let's say g. X goes to cosine of x times exp of x cubed. Compute the first 7 derivatives. So for n from 1 to 7 do, and I like to write in my n do so I don't forget. And how do you compute the nth derivative? It's d add n of f of x. Ooh, they get pretty complicated. Let me prefix this with an n so I know which is which. Oops, this should be a g. Oh, sorry. Okay, so here is g. This is the first derivative. This is the second. This is the third. They get more and more complicated. But this is the 7th derivative, and you can be pretty glad you didn't have to do it by hand. Problem 10, we have two functions, g and h. So g is the function x to the 6th plus exp of x. And h is the function, oops, I always make that mistake. G is the function x to the 6th plus exp of x. And h is the function 2 over x. Right? X to the 6th plus e to the x, h over 2 of x. So what is the composite function? G, what is it? Add h of x. G of h of x, you put 2 over x in for x. So you get 2 over x to the 6th, 2 to the 6 over x to the 6th. Yep, that's g composed with h of x. And the derivative of g composed with h of x is this, which we can simplify if we like. Yeah, a little bit simpler. So this is the function, g composed with h. This is the function, and this is its derivative. And if you compose in the opposite order, you get a completely different function. So if you take h composed with g, this is the composite function, and it's not really very much simpler, so I can forget this. And this is the derivative. Problem 11 is to factor certain polynomials for n from 10 to 17 due, n due. And what we want to do is factor the polynomial x to the power 2 times n minus y to the power n. And here they are. Let me prefix this with an n, so at least I know which. So when n is 10, this is this, this is all these factorizations. 16 has a lot of factors, 17 has very few. That's what it is. Problem 12 is to factor the numbers from 2000 to 2500. Sorry, to find the prime numbers from 2000 to 2500. So we can say for n from 2000 to 2500 due, and then n due. And what do I want to do? If is prime n, that means if n is a prime number, if that statement is true, then print the n. And then just as do has to end with an n do, if has to end with an end if. So this should just print out the prime numbers. And there they are. I could have changed the program to actually count this number if I want to know how many there are, but there they are. So that is the whole exam, and we are done.